So this is going to be a quick video on how to build one of my TinyTraks. I've been asked how to actually do the electronics in this, so I'm going to kind of do a one-cell build on camera. I have built two-cell builds. I prefer the one-cell builds just because it's kind of easier only managing one battery. And this actually uses a boost converter to get slightly higher voltage out of that one-cell LiPo so we can have a little bit more power out of our motors and a little bit more speed. So I'm actually not going to be building this specific TinyTrak. This is my own design. It's the PilotTrak V2. It's a pretty good off-road capable machine. The one I'm going to be building today is actually a revision of this. It's the Mini version. It doesn't have the idler wheels, and it's a shorter wheelbase. It's almost no bigger than a regular Tiny Whoop. And that's going to be a little less focused on off-roading and more for just kind of bowing around the house. So we'll get to actually building this thing. So first off, here's all of our plastic parts. I've got these printed in white PLA because I have a lot of that on hand right now. And I've got my tracks, which are printed in 95 Shore Hardness TPU. And I printed them in hot pink because I also have a lot of this stuff to burn up. And why not make something a little wild? So our main parts are the lower chassis that's going to house the motor and the electronics. And we got our upper chassis. This is going to house the battery, the camera, and the LED lights at the front. Our little camera housing goes on top of there. I already have the camera locked in its housing. That's going to mount on there as well. And then our battery cover just snaps on the back of there. So we've got our idler wheels. I already have my drive wheels attached to motors. And we will get to that after we get all of our electronics done. So laid out here we have most of our electronics. We're going to be doing a one-cell build because I find it to be the simplest to wire, and having less batteries is just kind of easier to manage. So what we're going to do is we're going to have this boost converter here, and this is going to take our LiPo voltage and boost it up to whatever voltage we want. The safe voltage to use would probably be about 6 volts. Most electronics are fairly compatible with that. It gets you decent power out of most motors. With this one, I looked up my specific receiver, and it's good up to 10 volts. So I'm actually going to be putting this up to 8 volts with a little bit of margin for safety. And that's going to get me just a little bit more speed and power out of these motors. Again, I recommend 6 volts because that's probably the safest option. So now, because we're boosting it up to 6 volts, we're going to want to actually keep that LiPo voltage for some electronic items, in this case, the FPV camera. So our incoming power, we're going to actually split off, and we want that LiPo voltage to go straight off to this camera. And I'm actually going to run my LEDs straight off of that voltage as well. The reason for that is this little voltage regulator built into the camera is really designed for one-cell LiPo operation. If we put it too much higher than that, it might overheat this regulator trying to burn off that extra power. And it's just a little bit more efficient to not run a voltage regulator after a voltage booster. So we're going to be running that directly off of our LiPo power. Now, on the other side of this board, we have the output from that voltage booster. And that's going to be our voltage that we're going to use to drive both the receiver and our ESCs. Now, these aren't actually ESCs. Right now I'm using disassembled SG90 servos. This does work in a pinch. They're not as good as dedicated speed controllers, but one-cell brush speed controllers can be kind of difficult to source, and they can be kind of expensive. So while I do recommend using a dedicated one-cell speed control, these SG90 servos do work in a pinch if you remove the circuit boards from them. The only thing you have to really watch out for is to keep the potentiometer attached to there, and once you have your receiver all bound up and everything all trimmed on your radio, you're just going to want to trim this potentiometer to make sure that this stops spinning, and that'll be your center point or your neutral point on there. And then once you get that set, you can just kind of use super glue or hot glue to kind of make sure that doesn't ever move. Now, the downside is there will always be a little bit more drift with these, and they don't put out nearly the same kind of power. But that's kind of the compromise you make, I guess. So now the way we're going to wire this up is with this receiver is actually going to act as a power distribution board. Because we're running our motors and our ESCs and our receiver all at the same voltage, we don't have to worry about having separate sources for our electronics and for our motors. So we're basically just going to run the voltage straight from this output, straight to this board, straight to our speed controls, in this case servo boards, and straight out to our motors. This is probably the simplest method to wire up a TinyTrak. It requires the least amount of soldering, the least amount of wires, and it usually works fairly okay. Now the order we actually want to wire up on the receiver is probably going to depend on each receiver or each transmitter, the way we have all the channels set up. But on my Spectrum receiver here, the order is throttle, aileron, elevator, and rudder. Now the ones we're going to want to use are the aileron and elevator, because then we can use elevon mixing in the controller. And elevon mixing does basically what we want for tank style mixing. It'll allow me to run the entire tank off of the right stick, and it'll mix the inputs, so that way both the motors will run going forward, backward, left and right, and then we don't need any sort of fancy onboard circuitry to handle all that. It's all just done in the radio. Alright, so now I'm going to start soldering this up. This one is going to be my elevator output. Now, you can use basically any receiver that has a pulse width output, so to like a standard servo. As long as it's got each individual output channel, you should be able to use it. This is actually a full-size receiver that I'm using, but I just removed the pins. There really isn't a whole lot of room inside these designs. I like to keep my TinyTraks very tiny. So you'll either need a micro receiver, or you'll just need to kind of make a couple compromises or cut off the pins. And it's usually not that difficult to desolder the pins on one of these. Okay, so now we have everything wired up as far as that goes. And I think at this point I'm going to start mounting it all in the chassis. So this can be kind of a tight fit to get into here. What I'm going to do is I'm probably going to just, okay, right, aileron. I'm going to mount my motors in here. I may end up having to shim that wheel outward a little bit, but should be fine for now. Now I always just use double-sided tape, 3M tape, Gorilla tape. A lot of that stuff works really well. The clear stuff tends to not stick too badly to things, so if you ever want to salvage parts for another build, I recommend the clear stuff. It usually pulls up really nicely without leaving any residue. It's kind of like a jelly tape. But that's what I use on almost everything. And I used to race a lot of RC cars, and it holds up to bashing those things around. So if it'll hold up to that, it should hold up to something like this just fine. See, there's very little room in here, but I think I'll get it all to fit. Nothing holding the top of those in yet. Okay, so I'm just going to tidy up my wire for that now. It should just mount right down there. Now you may notice I'm not using any sort of capacitors. That's because I'm lazy and don't want to waste any of my capacitors. I mean, these motors don't really draw a whole lot of current. They can be a little bit noisy, but modern receivers have just gotten so good at filtering out noise that I honestly haven't had to install filtering capacitors on much of anything recently. Quadcopters sometimes, they do produce a lot of noise. But something like this, I mean, unless I experience a lot of trouble with it, I'm not going to really bother. I did use an analog receiver recently. There's, what was it? There's, well, here, I'll show you. Well, no, I don't have it on hand. There's a really cheap, like, garage door key fob type of transmitter that was really cheap on Banggood, and I thought about using those for a TinyTrak, and after some testing it does work, but it's really susceptible to noise, so I'd use a lot of filtering capacitors on there. Alright, so we have all of our electronics in there. You can see it's got a little bit of room to spare, but that's about what it looks like. Let's see, I'll probably leave my antenna to stick out of the top of this little vent here. That should be just fine. Alrighty. So now I'm going to use a couple screws to just screw down this top. I'm not going to test this first because, you know, YOLO, I guess. So now these are just using standard M2 screws. This looks like, I don't know, maybe like an 8mm screw. Really, as long as it's long enough to make contact with the threads, you should be fine. It's not too critical on the length of these. Just snug. This one might need a little bit of assistance to get that motor down. Oh yeah, that should be good. Yeah, this lid serves two purposes. It, you know, keeps everything in. Well, I mean, I suppose that's one purpose. It's keeping everything in. Everything includes the motor. Not dual purpose, it's just one big shared everything purpose, I guess. I'm rambling. Okay. Okay, I'm going to have to loosen that a little bit. It might not be a bad idea to install a washer or something on here. Alright, so I'm actually just going to use a washer, 3mm washer, to shim these wheels out just a slight bit so they don't get caught up on the side of the actual track here. And just a dab of super glue to keep that wheel on. These wheels, when they print, depending on the tolerance of your printer, can be kind of tight if your layers kind of alternate in tolerances. Oh yeah, that's a lot better. So if you need help getting the wheels on, you can actually heat the shaft of the motor just a little bit with a lighter, and that'll make it just kind of slide right on with PLA. It's not like the best solution ever, but it does work. Okay, so adding the second shim. Add a little dab of super glue. That way I'll never be able to get that off ever again in my whole life. Perfect. Alright, so now we got those. So we got our rear, well, our front and rear idlers. This is an M4 screw. And I've got a washer on there as well, just like the other side. I'm just going to make that just snug and back off a little bit until it gets free. Perfect. That should do. Do the same thing with the other side. Again, just get it in there, back it off until it's rotating freely. That should do. And maybe a little looser. Perfect. Alright, so at the point that now I got all the wheels on and everything looks okay, I'm just doing a quick test of everything. So now, like I said, I got Elevon mixing set up. So if I go to my monitor here, you can see that when I push forward, and I had to actually trim these servos. In order to get the full resolution range out of them, they're very sensitive. I had to limit them to only 30% throttle because it interprets that as 100 on the servo. That's just how the servo works in order to get the right type of response on a servo. But you can see my left and right ailerons are both going forward and backward in tune with each other. And if I look at my actual model, the wheels are spinning in the correct direction, left is left, right is right, so we're all good. Now I did do that all before I put it together. You'll probably want to do the same thing, otherwise you're going to get this far, you're going to be frustrated, and nothing's going to work. Although, if you are clever with your radio settings, you can switch it all around, though for some people you may just want to instead swap the motors or switch the polarity on things. Another little feature I have on this chassis that's kind of optional, but I really do recommend it. I got these little eye hooks, and it'll actually thread in on the back axle here, right below the motor. And this kind of serves two purposes. Originally I kind of wanted to make a TinyTrak for running cable in tight spots, or running like a leader wire, or just something like that. But this also works as a wheelie bar. If it gets too far up an incline, instead of just tipping over, it'll want to hop up onto that wheelie bar, it'll lose traction, and it'll just fall back forward instead of wanting to tip over. So now that we're this far, we basically have a drivable TinyTrak once I put the tracks on, but we don't yet have our voltage booster in there. So at this point, if you wanted, you could actually just hook up a LiPo to it, call it good if all you wanted was just a regular TinyTrak that moves a little slower. But I'm going to hook this up. So what I'm going to do is I'm actually going to mount it at the very front of here. I should be able to fit a small LiPo right behind there still. And then once I have that all hooked up, I'll be able to test that. Alright, so now I'm going to mount everything up to that regulator. So here we have, I believe this is a Caddx Beetle. It's just kind of a fairly standard tiny whoop camera. I don't know if there's exactly like a standard size for these, but a lot of them seem to be really similar in size. And most of these really tiny ones seem to fit just fine in this little mount. You could mount this other ways, but this little bracket just kind of gives you a screw hole to mount to. And the way I actually pin it in there, it's kind of a quick and dirty method of doing it, but I left a little bit of extra plastic out the back of here, and I just take the soldering iron and I melt it till it gets warm and bend it over to kind of seal up the back of this. You could just press fit it in there and add a little dab of hot glue, but I don't know, this way just works for me. So now this I'm going to mount directly parallel with my battery leads in. Okay, so now that I got both of our LiPo voltage items attached. I'm just going to kind of twist that wire up and hope they don't break. I'm now going to be putting my main power out from the boost converter, and then we'll be all done wiring. So on this particular boost converter, I actually chopped off half the circuit board because it was unnecessary and just took up a lot of space with solder pads. So I'm soldering directly to a couple ground points on here. And then the output actually comes out of this diode out the front here, so I'm just going to quick solder to that. And we should be good. So at this point I'm just going to mount up my servo tape and we'll close up the rest of it and we should be good to go with our TinyTrak. Again, clear servo tape does wonders. Now it's harder than you'd think to work with a camera above you that you can't get your way. You're getting your way. Okay. Perfect. Now we have adjustable camera tilt. I'm just going to put it about neutral for now. That should probably be fine. Now when these are new, these can be a little bit tight as far as the battery compartment goes. I usually end up shaving off just a little bit on here with my handy dandy pocket knife. Remember kids, always cut toward you in a really jarring motion. Okay, that should be fine. So now this will just pop straight on here. And it's still a little tight. There we go. Now once I leave that on there for a little while, it'll loosen up. Sometimes when they're new, you just gotta kind of pry it on and off. Of course, this is another thing that can just be sanded. Yeah, that time it went on a lot easier. Now these tracks, they are directional. I've got them positioned so that way they kind of scoop forwards. That way if you're coming up to the edge of something, they kind of grip onto the ledge and pull themselves over. It's a way of kind of getting traction on something that doesn't really have a whole lot of traction. Ooh, these little bitty tracks are a little bit harder to get on than the bigger tracks just because there's not as much material. Okay, there we go. Easy peasy. Oh, that looks cute, doesn't it? See, I might give one of these to my nieces. This might be a good candidate for that. Although, my one niece does not like pink. Fun fact of the day. There. So now we have my battery compartment not closing because of that wire. And I'm dropping things. Perfect. Now we have one very tiny TinyTrak. That actually looks cute, and I thought it would in pink. I really like that. So now we got TinyTrak and our full-size TinyTrak. You can see just how much smaller it is. It's very tiny. I mean, here, I'll go get a tiny whoop for comparison, but this one doesn't have a camera on it right now, but tiny whoop for comparison. Not much bigger. Alrighty, so now the moment of truth. So does she work? Well, take my, oh yeah, that 380, that fits right perfect in there. So, got my monitor on, got my transmitter on. Let's see if she lets out the magic smoke. No, of course, it works. Perfect. By the way, I know everyone uses the goggles, but I have a better experience with the TinyTraks with just a screen. I think it's because I like actually watching the little thing move around. I don't like being stuck in the goggles, I guess, but oh yeah, that's neat. I like that. You can see even with those servo controllers, like I got a decent amount of power. They got pretty good resolution. Like I can move pretty gosh darn slow with this. Yeah, I really like the controllability of that, and it's fast enough, I think. Alrighty, so I think that build actually went pretty well. Sorry if it took a little longer than you're expecting. Not that great at editing or making these videos yet. I just recently got this webcam set up with the overhead cam, so I'm just kind of getting used to that. I don't really ever work on cam, so I'm just kind of trying to get the hang of it and make it, you know, actually kind of reasonable to watch. But yeah, this is a pretty good build. I'm really happy with how this thing turned out, actually. It's kind of fun to drive around. So I think this one will be really good for just kind of keeping in, like, I mean, heck, I could throw it in my bag and bring it anywhere with me, really. I got a tiny little monitor. I could just really bring it anywhere I go and just kind of bebop around with it. And this one's a little bit bigger, not much bigger, but this one's really excellent at off-road and going over just a little bit bigger objects. So if you're more into the off-roading with the TinyTraks, I'd recommend this, PilotTrak V2. This one, if you're interested in just kind of compact roaming around, PilotTrak Mini. Both of them will be available on my website, pilothobbies.com. Surprised the domain name wasn't taken because that's a really good domain name. Yeah, check it out. I got a blog on there. I have stuff besides just the PilotTraks. Coming out with a couple things. I got this entirely 3D printed robot design. I'm actually coming out with possibly an open source TTL logic circuit for it. This one doesn't use a microprocessor. It's just got a bunch of 555 timers to make it work. But it's a little too complex to build, really. So I'm kind of making a simplified version. Also making a mini version because this one it's a lot to print. So I think a mini version of that would be good. Might be good to make a FPV version out of too. Also aircraft design, Pilot and Pilot Hobbies. This is my new Delta Wing design. Very easy to make. It's a K&F airfoil design. It's just a stacked airfoil, so it's really easy to build. It's just about a half a sheet of hobby foam. You can get the hobby foam at like Michael's or something for like $5. You can make 2 of these out of that. You just kind of cut it, trace it, done in about a half an hour. Really easy build, flies really well. It's really fast, actually. So, anywho, if you like it, check out more on Pilot Hobbies. If you like this video, like and subscribe. I hope I'll be putting out some more. So, thanks.